Thank you so much for joining us.
Thank you.
You drove all the way from Tahoe,
I did.
but I said it's worth it because you live in Tahoe, right? For those of you guys who don't know, Summer is an author, you're a speaker, you just wrote a few books on GraphQL and React, so we're really excited to hear about your book.
Thank you. So we're going to talk a little bit about GraphQL, and I'll try to leave some time for questions because I think you're going to have a lot of questions. But I'm going to try to cover why, what, and how about GraphQL. And this is a GraphQL query, by the way. So I believe GraphQL turned 4 this year, but I've known GraphQL for about a year. But it's been a very good year. I've created 2 Pluralsight courses about GraphQL. Hack somehow convinced me to write a book about GraphQL. It's my first printed book and probably the last. It's so freaking hard. And I do some workshops on GraphQL as well, Forward and React.js Camp. So we're going to dive into why. Why do we need GraphQL? And we have a client and the server. This is the story, and the client needs data from the server. So we put GraphQL in the middle. Now, with this picture, GraphQL is kind of redundant. Why do we need another layer? But I'm going to give you the most popular reason for GraphQL. And the most popular reason is that the client needs multiple resources from the server. And the server speaks the resource language. It says, I know people, I know events, I know so-and-so. So with GraphQL, we can satisfy the question about multiple resources in a single round trip. This is like the extreme benefit of using GraphQL. But there's like 10 more benefits that you get to. If you have multiple clients and if you have multiple data services, GraphQL do all the logic of communication between all these elements. So instead of a client going to 2 data services, you can just have it ask GraphQL, and GraphQL will communicate with multiple data services. But let's go back to the definition of GraphQL. So the official definition says data query language and runtime. And it's important to note that it's 2 things, not just one. So it's a query language plus a runtime. And there's a reason for this. So GraphQL is a query language, right? We can teach it to a client, and the client will start speaking GraphQL. Yay, I'm going to be able to ask a GraphQL question. The server will be not understanding what's going on because the server does not understand GraphQL. And we could teach the server GraphQL, but the server probably is already speaking some other language because GraphQL is not a storage engine. So there has to be a database or something. So this server speaks SQL, does not understand GraphQL. We put a GraphQL runtime in the middle, and the runtime is going to translate to whatever the server understands, and the server will be OK with that. And GraphQL can translate to multiple services, whatever the other service is speaking, all these languages. So this runtime is designed to play really well with all the data services. And then the client needs only to speak GraphQL. OK, so GraphQL has a lot of features, but the most important features is that it has a type system. GraphQL is strongly typed, and this is baked in the design of GraphQL. And this type system allows for features like introspective API and cool things that I'm going to try to mention. But the biggest thing about GraphQL is that it speaks to the data as a graph, and your data is a graph. If you want to represent your data in a data structure, it's a graph. So GraphQL runtime allows us to represent this actual graph of data with a graph of API. Those are the cool scientific things about GraphQL, but what I really like about GraphQL, and I think the killer feature and the game changer, is that declarative nature of speaking the data requirement language. Prior to GraphQL, we did not really have a good solution for speaking data requirements, and GraphQL is trying to innovate there. Again, this is all scientific. If someone at work asks you, what is GraphQL? Well, it's a REST replacement. GraphQL allows to create APIs to replace REST APIs. And the question that should be immediately in your minds now is that, what is wrong with REST? And I'm going to tell you. The biggest problem is multiple endpoints, right? REST is a resource-based resource. You have multiple endpoints. Every endpoint represents a resource, and if your client is asking for multiple resources, it needs multiple endpoints, multiple round trips to the server. This is the biggest thing that GraphQL is trying to solve. But there's a lot of other problems. I'm going to go through them. There's no client request language. Basically, with REST, you go /people/for. Okay, what do you want from people? Do you want the name, the email? There's no language to express the data requirement. And this means the client don't have control on what you can get from the server. The server is completely in control. The logic of your data requirement is hard-coded in the server. So those two problems, and this leads to other problems like, I'm going to give you all the data, whether you need it or not, right? And perhaps the biggest problem of all is when you start versioning your API, because you have to support multiple versions, and you start doing code duplication between those versions, and then it becomes a real mess. Now, I'm not mentioning all the problems of the REST, and I'm not really, I don't want to get into what is REST and what is not REST. We know like the resource-based things that we do. Every REST API turns into custom ad hoc API at the end because you want to customize for performance, right? But those are the basic problems that are specific to GraphQL. GraphQL is trying to innovate there. How? Well, single endpoint. The GraphQL server is just a single endpoint. That single endpoint is it's like taking this custom endpoint idea to the extreme. Because to make RESTful API performant, you do more custom endpoints. So GraphQL takes it to the extreme. We are just one single custom endpoint that replies to everything. Now that sounds like magic, but we'll get into it. If you have a single endpoint, you need the client to speak a language to describe requirement, because the endpoint is like /GraphQL. It replies to anything. So this is where the GraphQL language is needed, because it's a client request language, which does not exist in other APIs. What does this mean exactly? Well, it means that the client is in control, because the client specifies the requirement of their data, and the server will just comply as long as the data requirement is within the server capabilities. And it leads to really cool side effects that you get exactly the data that you ask for. There's no more or no less. And also, when it comes to versioning, there's a unique perspective about it. Let's not do it. So basically, you can avoid the versioning problems by just introducing new fields for the query language to ask for. You keep all the old fields. And there's a strong reason why this is baked in the language, is that with mobile applications, with mobile clients, you can't really control the mobile client history. The user who installed your mobile application 5 years ago, you can't control the version of the data they asked for. So you'll have to keep supporting it probably forever. So you can avoid versioning altogether with GraphQL. Okay, so this all sounds good, right? But as Andrew said, good things are hard to use, right? So I'm gonna show you, let's take an example. That's not the screen I wanna show you. How do I, sorry. Let's mirror this. Where is it?
Probably on the other screen. Click gather windows on the projector screen.
Thank you. No.
Oh.
So I am gathering mirror displays. Got it.
Got it.
Thank you. Yeah, I'm not a Mac person. I used to be a Linux person. I'm trying to be Mac. Okay, so here's a UI, right? This is it's an Angular template. I just made it Angular. It was React, so I know this is an Angular crowd. And I'm not very good at Angular. If I'm doing something stupid, let me know. So this is an Angular template, and it's basically a UI component to represent a Star Wars character, right? Very simple, person name, birth year, planet name, and the list of all the title of the films that they appeared in. And I want you to think, for just a second, how to ask for this data from a RESTful API. You need 3 resources, because you have person, you have planet, and you have film. And the first API hit you're going to do, so basically, well, think about the data structure. Like what JSON satisfies this UI component. And this is one possible data structure. Person object that has name, birth year, planet, and the planet is an object, and then the films is an array of objects, right? So when you think about this in terms of resources, you're going to start with planets, and then the ID of, sorry, you're going to start with person, people, and then the ID of that person. And you'll get this information from a RESTful API. You'll get that stuff that you asked for, the stuff that your UI is actually using, and you get a lot of other stuff that you don't care about. But after that, this is not completely REST-ish, right? But after that, you have to hit another endpoint for the planet, and you have to hit 4 endpoints to get the information for the films. So in total, you're hitting 6 endpoints. But that's not the only problem. After you're hitting 6 endpoints, you have 6 JSON responses that you need to put together for this simple UI to be satisfied in terms of data requirements. So that's 2 problems, right? You have multiple round trips, and you have logic on the client to make this data requirement work for the UI. While with GraphQL, you just do that. You just say, hey, GraphQL, give me my data in this shape. And basically, this is the GraphQL query to ask for the same information here. And I want you to think about, look at this GraphQL query, and remember the question that for the data that we need in English. We need a person, names, birth year, planet name, and film titles. That's in English, and that's as close as it gets to what we think about in terms of our language. So I think like front-end developers are going to love GraphQL because, well, the mental model around it, it's very close to how we think about our UI. And I'm going to talk a little bit about that. So, how much time do we have?
Yeah, you have like 15.
Okay, cool. So this is a GraphQL query. It asks for first name, last name, and email for employee ID 42. And you'll notice how the field, we call this employee, this is the resource basically, and those are the fields that we want. But every field in GraphQL acts like a function. It takes some kind of input. In here it's taking ID 42, and it gives back an output, which is the data that we are interested in. And again, exact fetching going on. So if your table has a lot of other information, as a client, I don't really care about all this information. All I care about is just first name, last name, and email. While with REST, you're gonna get all the information, right? So here's the data, and I want you to compare the query with the data. This is the best thing about GraphQL, in my opinion, is this mental model. If you have the query, you know how the data is going to look like. And if you have the requirement, this is the requirement. If you have the requirement, it's really easy to come up with the query. So this mental model is something really great about GraphQL. So GraphQL, again, back, it's language and runtime. And the language has a lot of features. We have queries and mutations. Mutations for update, delete, insert operations. There's also things coming to GraphQL, like there's subscription for real-time data. So you ask about a data requirement, and then the server will register this question and push update for that data to you. There's also a big thing about GraphQL called fragments. And fragments is how we compose our bigger queries with smaller queries. And it really is associated like one-to-one mapping with UI components, because your UI is basically composed of multiple components, right? So instead of having one giant GraphQL query to satisfy all the data for those hierarchical components, you can have multiple fragments and map fragment to component one-to-one. So every component has a partial requirement through a fragment, and then you put all the fragments together and you take it to the server. And this allows for responsibility management in the UI, right? And The runtime on the server side has features like, well, you need a type system because GraphQL is strongly typed. But the runtime is responsible for things like validating queries before parsing them, before taking them, and satisfying their results. And actually, the execution part of the runtime is also huge because you have things like parallel execution if you need to go to multiple data services. And perhaps like one of the best thing is the introspective API. You can actually ask a GraphQL server about its capabilities using GraphQL itself. And this allows for really rich tooling. And I'm going to show you one of those tools. So here's some examples. There's like features like variables. In the queries, we can use variables, especially like in this mutation. We have variables, so we can reuse it instead of string concatenation at runtime. We can have, GraphQL itself is interface agnostic. It doesn't need HTTP, but potentially HTTP would be one popular choice for web applications. But we send the request somehow through an interface. Let's assume that's an HTTP. We send the request. It could be /GraphQL. Here's my query, and here are any variables in case the query uses variables. And then the server can send us a response using JSON over HTTP. This could be over sockets or SSH or anything else. So I'm going to show you quickly. This is all cool, right? But I'm going to show you quickly how a GraphQL schema look like, because this is the hard part. Again, front-end developers are going to love it. Back-end developers, not so much, because it's a lot of work. So I'm going to show you, well, let me first show you quickly here. Let's take this. Let me show. So this is called Graphical. This is a tool to explore GraphQL queries before you can actually take them to production. And because of the introspective API, this tool knows everything you do. So when you're here, it knows exactly. Oh. Why does it keep doing that? Just mirror the displays. Gather windows. There you go. It's not gathering. Gather windows.
I think gather windows just puts the preference windows together.
Mirror displays. I found it. Cool. So, okay, so this is called Graphical, like pun name, right? But because of the introspective API, it knows everything about the API. And this is a local API from the Star Wars data itself. So Facebook took that as an example, the REST API around Star Wars data, which is swappy.co, and it built a GraphQL representation for that RESTful API. So just because of the introspection, you know exactly on every level. So if we're like go to a person level, or yeah, let's go to a person level. And then if you go here, it gives you like highlight what's going on. I'm missing some name here. This is all available to you because of the introspective API. So I'm gonna go with like, what about here? What can I do here? Well, tell me, you can either do an ID or a person ID. And then if you like type wrong data here, it will tell you that you, well, let's go with like, how about here? Yeah, name. So, oh man, because it's local cache. So let's go with that. So here's Darth Vader. And then if I want, I think it's called Homeworld, you go there, name, and then if you want films, you can start typing and it will tell you what you can do and you can't do. Connection is a relay thing. But again, title. And I'm going to show you actually what's going on here in the backend. This is the API endpoint when I ask for Darth Vader. And I'm going to go ahead and ask for this information. And I get the same information in one round trip. However, the API really made all that 5-6 API hits to the cache. This is all from the cache, but it demonstrating what is going on with the REST API. So this is called Graphical. There's GraphQLHub.com, which has a lot of good example APIs. They have, for example, GitHub. So if you want to explore the GitHub API, you can do something like that. And because, well, the GitHub API is like, the GitHub API is also RESTful. So this is grabbing the RESTful API. So let's take a look at the schema. This is a very simple schema, the hello world of GraphQL. It's a JavaScript implementation of GraphQL, so we're doing this in Node. And basically, the schema is just an object instantiated from the GraphQL schema, and you give it a query root type. And the query root type is like, for every graph, you have to have starting point. So this defines the starting point that are allowed in this graph. And I'm only defining a single starting point. So this is a graph with one node. And you can see how everything is strongly typed. So everything has a type. And then the resolve is the function that I was talking about, that every field maps kind of to a function. So this function is resolving with the string world, and we can execute it with node, this file, and then you give it a query. And I'm executing with a very simple interface, no HTTP or anything. It's just command line argument, and it will just reply. Okay, very simple. Not very interesting. So let me show you a more complicated query. This is or field type. Let's talk about type. This is a type. This type represents a user record in the database. This is actually a user record that has data in both Postgres and Mongo. So you'll see how we have subtypes that we require. We define the types on the fields. We can have virtual fields that are constructed from other fields. And then we have relations. So this contest, one user has many contests. So it's a one-to-many. And you'll see how it's going to the database to fetch contest for this user ID using a loader here. And I'm here using data loader. Because if you do this without a data loader, you have a lot of problems with like n+1 problems. And data loaders solve these problems. Same thing here. This is actually going to Mongo to fetch votes count, and then activities is this is how we say this is a list of objects. So this is the type of this activities field is a list of activity type, and then activity type is its own file. So this is an example of a type that actually works with data. Now, to start with GraphQL, maybe, because working with servers is really hard. There are options with like hosted GraphQL, and a lot of businesses are starting over hosted GraphQL, and this is one of them. I haven't actually used this, but I know the team who's working on it. So GraphQL is one of the backend hosted GraphQL that you can start working with. It gives you the API ready, and you just manage your data. And in terms of client that works with GraphQL, of course, Relay is the most popular one. You don't need Relay to work with GraphQL. Like GraphQL is its own thing, but Relay is one JavaScript client that is designed around GraphQL. And there's another one. There's the Apollo stack. Someone mentioned the Apollo stack. I hear good things about it. I haven't used it yet. And of course, GraphQL is not just for the React because it's famous with React. There's a lot of enthusiasm about GraphQL in the Angular world as well. And yeah, so let's do some questions. If not, I'll show you more. How does it scale? How does it scale? Perhaps I'm not the best person to answer that, but really, as I said, there's this project called Data Loader. This is for scaling your Data Loader JS. You should probably do JS. So this is a project from Facebook, and basically this project is to delay the execution of all your data queries into and batch them together. So if you have multiple things that you need to ask for, because it's all hierarchical and you're resolving on every level of this hierarchy, if you don't have a data loader, you have a lot of SQL queries. This is scaling between GraphQL itself and the data service. So data loader manages the cache and batching operations for all the resolving of these statements. Now, to scale, like you can add multiple services, like for GraphQL itself. I know GraphQL is powering the newsfeed at Facebook, so it's like they have a stack that has billions of requests per day, and it's working for them. But you know, if you're not Facebook, maybe